In today's notes, let's look at the converse of the Pythagorean theorem. So the converse can be used to prove a triangle is right. Example 4 says determine if the following are right. So if I apply the Pythagorean theorem, which says a squared plus b squared is equal to c squared, where c is the side that is the longest and it's across from the 90-degree angle. Let's see. If we're looking at the longest, well, that would be the 8. So that would be our c, and our a and b really don't matter. Does 5 squared plus 6 squared equal 8 squared? Let's see, 25 and 36, does that equal 64? No, if I add these two together, that gives us 61. And 61 does not equal 64. So this is not a right triangle. All right, let's try this next one. 7 squared plus 24 squared, does that equal 25 squared? Remember, you're always looking at the longest side. That's going to be your C. And so let's see, 49 and 24 squared, I've worked that out. That's 576, and 25 squared is 625. And if we add these two together, let's see, 576 and 49, 15, let's see, 11, 12, and that would be 625. So yes, these three are a Pythagorean triple. Pythagorean theorem does work, and if it works, then we know that the triangle is right. So as a right triangle. So this is a yes. All right, one last. Okay, so this guy is our C. He's the biggest number. 1 squared plus 1 squared, does that equal 3 squared? Well, 1 and 1 do not equal 9, and so this is a no. You can also use side links to classify a triangle as acute or obtuse. So remember, if we have c squared equals to a squared plus b squared, we know that this is a right triangle. Now, if c is the longest side of a triangle and a and b are the lengths of the other sides, if c squared is greater than a squared plus b squared, this is a greater than, then you have an obtuse triangle. If c squared is the longest side and a and b are lengths of the other sides, and c squared is less than, then the triangle is acute. So if it's equal, it's right. If it's greater than, it's obtuse. And if it's less than, it's acute. So let's take a look at some examples. All right, so remember, our C is always the biggest. So I'm just going to circle the biggest in each of these. These guys are my C. A and B don't really matter, but let's check it out. Let's see. So we look at it from this side. C squared, and then we're going to compare it to a squared plus b squared. So 7 squared compared to 6 squared plus 6 squared. 49 compared to 36 plus 36. Well, 36 and 36 make 72. So this is a less than. If C is less, then it's acute. Okay, so let's see. 7 squared compared to 3 squared plus 5 squared. 49 compared to 9 plus 25. 9 and 25 is 34. So in this case, 49 is greater, so this one would be obtuse. Okay, let's try one more. 5 squared compared to 2 squared plus 4 squared. 25 compared to, let's see, 4 and 16. 25 is greater than 20, and so this is obtuse. And that's how it works. Example 6, the lengths of the sides of a triangle are given. Tell whether each is an acute, right, or obtuse. Okay, so first let's go highlight the C's. C's are always the biggest. All right, and then we compare it. 20 squared compared to 9 squared plus 14 squared. And so 400 compared to, let's see, 81 and 14 squared. I do not know. I think that's 196. And so when I add these two together, 196 and 81, I don't know why I carried a 1 there. Hold on. Okay, that's 7, 9, and 8 are 17. So 277, so 400 is greater. That's obtuse. And this next example, I guess I'll write it over here. All right, in the next example, let's see. We have 17 squared compared to 15 plus 8. And 17 is 289 compared to 225 plus 64, and 225 and 64 is 289. This one's equal, so this is a right triangle. And let's see, here's the last one. 12 squared compared to 10 squared plus 8 squared. 144 compared to 100 plus 64. We can see that that's less because that is 164. And so less means acute. Example 7, determine if a triangle can be formed with the given lengths. If so, classify the triangle. All right, so if it's first of all, if we want to know if it can even create a triangle, the two shorter sides, the sum of those two have to be greater than the longest. So 6 plus 9 is greater than 12. And so, yes, this can be a triangle because the sum of the two shorter is greater than the third, or the longest. Now we need to classify it. So now we're going to take that C value, the largest value, compared to 6 squared plus 9 squared. So 144 compared to 36 plus 81, and 81 and 36, 8, 9, 10, 11. How about 117? So 144 is greater, and so this is obtuse. Okay, one last triangle. Let's see. Square root of 10 is bigger, so we need to see is square root of 5 plus square root of 5 greater than the square root of 10. Well, this is 2 square roots of 5, and we need to see, is it greater? I should erase that and just say question mark. How do I compare these two? I'm going to go ahead and go to my Desmos and get a decimal so that I can compare these. So I'm looking at 2 roots 5 and the square root of 10. So 2 square root of 5 is 4.47, and the square root of 10 is 3.16. All right, so we need to make sure that 4.47 is greater than 3.16. And so in this case, yes, we have a triangle. Now we need to classify. Well, let's see. Square root of 10 squared compared to square root of 5 squared plus square root of 5 squared. And this is 10 compared to 5 plus 5. This one is equal. And so this is a right triangle. All right, and